let's work backwards given the area of a kite to find the length of its diagonals. So I've already gone ahead and drawn my picture. You guys probably know by this point that I'm a very visual person, so I like to see what I'm working with. So I drew a kite and I drew in a couple of the diagonals. Now let's label some information they give to me. In this case, they don't tell me how long either diagonal is. All they say is that one of them is twice as long as the other one. So as we've done in some other previous problems in some other videos, I don't know either variable, so I don't know either dimension. So I'm going to go ahead and label one of the diagonals. I'm just going to call it x, because I have no idea how long that one is. I do know the other one is twice as long though, so I'll say the other one is 2x. It's twice as long as the other diagonal. So there's my diagram. Let's go ahead and start with our formula as we've always done, and then plug in some information. So since I'm working with a kite, I know my area formula is 1/2 times d1 d2. Where d1 and d2 are the two diagonals. So let's plug in what we know. The area will be given to us if we're working backwards. So 72.25 needs to be equal to 1/2 times one of our diagonals is just x, doesn't matter which one, and the other diagonal is 2x. So there's the equation I'm going to be working with to solve. Okay, let's go ahead and simplify some things in here. Because the right side of the equation, everything's being multiplied together, I can multiply stuff in any order. So what I would recommend you do is just multiply the numbers together first. So 1/2 times 2 is just 1. And then I can multiply the x's together. X times x is x squared. So that's what I want to be working with. Now, that number in front of the x squared, I need to get rid of that first. It doesn't really matter if it's a 1, I could just drop it off. Otherwise, if you ever have a number in front that's not a 1, make sure you divide both sides by that value first. But like I said, it won't matter if we're working with a 1. So 72.25 is equal to x squared. And if I finish this problem by taking a square root, I get an x value of 8.5. Okay, that's not necessarily my answer though. Let's go back and see what they asked us to do. We wanted to find the length of each diagonal, so we should have 2 answers when we're done with this problem. So I'm going to label as my answers, I'm going to just say d1 equals and d2 equals, the 2 diagonals. Well, one of the diagonals was just labeled as x, so one diagonal is just 8.5. Do make sure you include a label, since this is just a distance we're finding that's just a regular centimeters, not centimeters squared or anything. My other diagonal was twice as long as that one, so multiplying 8.5 times 2 gets me a diagonal of 75 centimeters. So that should be the 2 lengths of the diagonal that get me an area of 72.25 centimeters squared. If I want to check it though, these are very easy to check and quick too, so you might as well do a quick check on it. Just plug those numbers into your formula and make sure that 1/2 times 8.5 times 17 does get you an area of 72.25.